The start of everything, but only the dramatic change from one cosmic chapter to the next. Interestingly, the most recent findings now even imply that Penrose is correct in his belief that the universe has always been undergoing a fixed cycle of destruction and rebirth. However, what about the enigmatic Hawking points, which Penrose claims are the remains of a former cosmos? For us, at least, infinity is finite. From our earthly perspective, we can only observe a minuscule portion of the universe, despite the fact that many experts assume it is endless. The area from which information may have reached Earth since the Big Bang is included in our spherical field of vision, which is aptly called the observable universe. The distance to our natural line of sight, or the so-called event horizon, is not 13.8 billion light-years, as one might assume, given that the cosmic birth occurred 13.8 billion years ago. The distance to the observation horizon is finally calculated to be 46.3 billion light-years, since the cosmos, or space, has been expanding continually since the beginning of time, lengthening previously covered distances retroactively. The fact that each location in the cosmos has its own observable universe is what makes this so fascinating. To put it another way, if a civilization exists billions of light-years distant, it can observe a region of space that will always be a vast mystery to us. Because of these cosmic blinkers, specialists are only able to make educated guesses about what is hidden from view. Some scientists estimate that the invisible depths of space are far more weird than we can even fathom, while many others think that the structures there are similar to those in the local universe. But the black hole that was just added to the star charts by the James Webb Telescope was also far stranger than we ever thought. Despite having existed for 1.5 billion years following the Big Bang, the gravity monster, known scientifically as Li 568, apparently consumed matter 40 times more quickly than is theoretically feasible. Let's be clear, though, this enigmatic Webb discovery does not represent an astronomical anomaly. Rather, it fits the new, perplexing trend of a whole class of black holes that seem just too enormous for their early origin. One of these is the quasar, J120+0641, an active galactic nucleus that is more than 1 billion solar masses in mass and dates from the cosmic twilight epoch. Unfortunately for the researchers, a closer look using Webb's mid-infrared instrument MEI did not uncover any unusual feeding mechanism. As a result, we are unsure of how a supermassive black hole could have reached full maturity when the universe was only 5% of its current age. New methods need to be considered, because the cosmic preterm babies of the observable universe cannot be explained by our current models. Sophie Kidman's comments illustrate how these can occasionally have the power to fundamentally alter our conception of the cosmos. The exciting thing about this question is that nothing is ruled out, the University of Cambridge scientists said when asked if the unexpectedly huge black holes could have evolved from structures that existed even before the Big Bang. According to others, a direct collapse must have created the bulk of black holes that we have now discovered in the early cosmos. According to a number of papers, the observations support this. Black holes have only enough time to develop from a very light seed if they expand efficiently. Kidman stresses that this model is only one of many possible explanations, but it does offer a novel idea, that something was before the Big Bang, and that this is the case for our universe, the cyclic model, which views the end as a beginning. The Webb discovery, which initially set off the astronomical crisis, also serves as evidence that modern cosmology has surpassed its boundaries in many ways. Indeed, as early as February 2023, it was reported that there were 6 improbable galaxies that were at least 13 million years old and as enormous as the Milky Way today. But because this surprising discovery was so at odds with our assumptions regarding the quantity of stuff in the early universe and the formation of galaxies, the unexplainable objects were soon dubbed universe breakers. In the early cosmos, it seems that some galaxies were far more effective than others at turning gas into stars. A research team from the University of Geneva, which examined 3 galactic heavyweights, known as the red monsters due to their appearance in the Webb images, at least came to that conclusion. Our models suggest that galaxies originate in dark matter halos at a relatively modest rate. These gather atoms and molecules and use their gravitational pull to bond structures around them, which is how galaxies form. However, in the case of the red monsters, the equivalent fraction is a staggering 50%, since normally only 20% or less of the collected gas is transformed into stars. Once more, however, how the structures accomplished this, some 1 billion years after the Big Bang, is still a mystery in astronomy. We only know that the incredible expansion of galaxies must have been made possible by an event that occurred in the early cosmic chapters. However, what if that isn't the case? To put it another way, what if the universe's basic structure had been established earlier than the Big Bang? In such case, we would have reached the central idea of a remarkable theory that Roger Penrose has been proposing for a while. The British mathematician and physicist, who was awarded the 2020 Nobel Prize in Physics for his studies of black holes, is certain that the cosmos is cyclical. Penrose therefore views the Big Bang as the transition between two eons of two cosmic life cycles, rather than the frequently quoted beginning of essentially everything. As the saying goes, every end is followed by a new beginning, and the universe would keep growing until all matter had broken down and turned into light. Penrose believes that this harsh environment, where nothing has a time or space reference to anything else, will eventually result in a repeated Big Bang. The black holes will likewise totally vanish as part of each cosmic finale, immortalizing themselves in the next universe as a unique remnant that attests to the preceding cosmos' existence. That's not all, though. According to Penrose, he discovered these recognizable remains in the cosmic microwave background. More specifically, this refers to a large number of circular spots visible in the WMAP and Planck satellite data. To put it simply, the cosmic microwave background radiation, or CMB for short, is a remnant of the early cosmos that was produced during the recombination epoch, some 380,000 years after the Big Bang, and it continues to pervade the whole universe to this day. We must first acknowledge that the cyclic model postulates cosmological inflation prior to the Big Bang in order to see why the discovery of so-called Hawking points could be so important. In general, this refers to a period of extraordinarily fast cosmic expansion, during which the universe underwent an unprecedented growth spurt right after it was created. However, we are dealing with the outcome of the exponentially increasing future of an earlier eon if we now position this inflationary growth prior to the universe's creation. Although supermassive black holes are an anomaly, since they would have nearly entirely absorbed the galaxy clusters in their surroundings by the conclusion of a cosmic chapter, the adjustment from eon to eon is solid in theory from both a mathematical and physical perspective. They would carry all of the radiated energy into the next universe as a single Hawking point before they themselves totally vanish into Hawking radiation. The photons generated by this process would then be located in an expanding region, which is only made visible when it eventually shows up in the new universe's microwave background radiation. Such a Hawking point would resemble a disk the size of the full moon on paper, and in reality, the data given have shown that the microwave background actually looks like that. The alarming spots are actually multiples of the typical CMB temperature changes, and experts had thought that cosmic inflation would have wiped away such features entirely. Is it feasible that our world simply corresponds to the current cycle and not the one universe at all, given this fascinating discovery and all the cosmological contradictions the James Webb Telescope has revealed? That's exactly what the astronomical controversy, which is still going strong, is about. However, several basic concerns still need to be addressed. Even if the universe is indeed undergoing an endless cycle of destruction and rebirth, what, then, signaled the cycle's beginning? Is there ever such a thing as an eternal beginning point? And can humanity ever be able to comprehend the universe it lives in completely? Who knows, though? However, you undoubtedly realize that if you want to ensure that you never miss another new video from us, you should hit the thumbs up and subscribe buttons. Please feel free to join our community in order to be informed going forward. See you shortly.